Welcome to the educational research section of www.happynumbers.org. Today's video will be dealing with histograms. Histograms, or one of several different ways of taking pictures or making pictures of data, graphic pictures, so that there can be a visual interpretation of the data. Again, almost all of the examples come from the Carnegie Mellon Open Learning website. Here is the URL down there. It's a fantastic website. Again, I'm not selling anything or anything like that, but I certainly want to acknowledge that the information comes from there. And the reason I am using it this way is to try and add a verbal explanation to the information that is presented. So let's take a look at then histograms, or graphic representations of some data. Now, once we're able to graphically represent the distribution of, or a set of data points, we can then start to describe that distribution in terms of its shape, because there'll be certain characteristic types of shapes that data will take. We can talk about the center, how the data tends to gather around the center, and we can talk about the spread of the data, and of course outliers or extreme scores or unusual scores. But we're going to be talking right in this video about the shape of data, the shape of the data. So let's take a look at that. Okay, now shapes of distributions, we want to consider the symmetry. Is it symmetrical or is it skewed? And the peakedness. In other words, the peakedness, how high it is, what are the peaks in the data. If we take a look up at this particular data, this is very symmetrical data, and it is uniform. The distribution is uniform. The data is almost all identical. So this is symmetrical and very uniform. If we look here, we have what looks like almost a traditional bell curve. So the data is very symmetrical, is about the same amount. If we had the middle point, is about the same below the middle as above the middle, as the same with this distribution, the uniform distribution up here. There's about an equal amount of data below and above. Here the same thing, but here we have a peak, a single peak. This data is very symmetrical, but it is double peaked, and this is called bimodal. The mode is that number in a data set that appears the most times, and this particular one has two modes. It's bimodal, whereas this distribution here would have one mode, would be the number that appears the most would be the high point here. And this probably would have no mode because everything is almost the same. So we want to look at the symmetry of the data. How symmetrical is it? Again, this one is very symmetrical and it's uniform. This is very symmetrical. We can divide it in half, and about 50% would be below and 50% above, but it has one single peak. This data is symmetrical also. If we divided it in half, it would be about half down here and about half up here, but this is bimodal. Okay, now distributions can be skewed, so let's take a look at a distribution that is left skewed. And here we have the count on the y-axis and the age of death. And this distribution is left skewed. The left tail are the smaller values. Most of the observations are on the right side, with a few that tail off onto the left. And a real-life application of this might be age of death. Very few people die when they're younger, as opposed to as we get older, then we start to die more often. And then when we get way old, then there are lesser deaths because there aren't that many people around at that age level. So this is a left-skewed distribution. Left skewed. Skewness is really important, by the way, and the concepts of symmetry, because there are certain statistical analyses that are done on data that are only appropriate if the data set is symmetrical. And there are other statistical analysis that are used when you have skewed data. Like for the skewed data here, for the measure of central tendency, you would not use the mean because the mean is very sensitive to extreme scores. So you would use the median as the measure of central tendency, and you would not use the standard deviation as a measure of variance or range because that requires a symmetrical distribution. So you would use the interquartile range as your variance here. Well, let's take a look at a right skewed distribution. Now, here's a distribution that skewed to the right. Most of our observations are in the left portion of the graph, and then a few extreme observations on the right. So the real life example of this might be a really, really hard test. Most of the people got very poor marks on it. Only a few got very high marks on it. So this is skewed to the right. And again, since it's not symmetrical, the appropriate measure of central tendency would be the median, and the appropriate measure of variation or range would be the interquartile range or the 5-number survey. So again, the symmetry of a distribution, all three of these are symmetrical. They could be divided in half and have about the same amount of data points on each side. But this one is symmetrical and it's uniform. This one is symmetrical, but it has one peak. This one is symmetrical, but it is bimodal, has two peaks. Now, since these are symmetrical, then the mean would be a measure of central tendency and the standard deviation would be a measure of variance. Since these two distributions are not, we have a left skewed here and a right skewed, the mean and standard deviation would be inappropriate, and the median and interquartile range would be the measures of central tendency and range. Okay, this is our Best Actress Award winner, Oscar winners. We've looked at this data before, and we can summarize the data shown below on this histogram. This is the graph of it. Here are our outliers and things. We can talk about the shape. Okay, the distribution of ages is skewed to the right because we have these three outliers out here, and the majority of the best actresses go to younger people. The majority go to the younger people. So that's the shape of it. We can talk about the center of the distribution. Well, the center seems to be around 35, or I think if we had a if we took the center point, it would probably be around 35. The spread of the distribution, the range is from age 21 up to 80. It's about 60 years. The outliers, I think we have 3 probable outliers. It says here 2, 74 and 78, but I think 62 is a probable outlier also. So we had 3 probable outliers. So looking at this shape of this distribution and the histogram, what conclusions might we say? Well, it looks like Hollywood likes its actresses young. Its award-winning actresses young. Okay, just very, very brief summary. Histograms, graphical display of a distribution of quantitative variables. Look to describe the overall pattern of the data, its shape, its center, and its spread. Deviations are outliers, data points that fall outside the overall pattern. When we're describing the shape, we want to consider the symmetry. Is it symmetrical or is it skewed? And that makes a big difference in the kind of data analysis techniques or statistics we would use. And the peakedness, or the modality. Is it uniform peakedness? Is it one mode, like a bell curve, or bimodal or trimodal? Well, that's it for histograms. A very convenient graphical display of data. Thank you very much. Hope to see you next time.